All right, so our demand function, demand is what drives our what? Price, the price we're going to charge. So this is lowercase p. Our revenue, the symbols that we use for revenue is just capital R. How do we find the revenue if we know the price function? What do we multiply the price function by? X. So it's X times P is going to be the revenue function. The cost is going to be capital C. When we refer to cost, we're talking about the total cost for X items. The profit function. To find profit, what do we have to do? Good. Revenue minus cost. And then to find C bar, that's the average cost per unit. This is when we would have to do the total cost divided by the number of items. And that would tell us the cost for one item. Okay. Next question. What is the rate of change of a function at a high point or a low point? Think of a function. Here's a high point. What's the rate of change right at that high point? 0, right? What about at the low point? What's the rate of change? 0. So the rate of change at either a high or low point is always going to be 0. So that helps us to decide what we're going to do on these problems. Find the number of units that produces a maximum revenue R for this function. So to do this, I'm going to have to take my function R, and I'm going to have to find the derivative of it. Because I want to know where is the change, the rate of change going to be 0. So I'm going to take the derivative, and I get 800 minus 0.4x. That's the marginal revenue. What do we do with that marginal revenue? What did I just say we're going to do with it? Set it equal to 0. Because I want to know where's the rate of change 0. So I have 0.4x equals 800. If I divide by 0.4, that's going to be 8,000 divided by 4, so that's going to be 2,000. So 2,000 is the number of units that might maximize our revenue. The problem is, though, when the slope is 0, it could be minimizing the revenue. So to check that, I have to do the first derivative test. So I'm just going to check that. I'm going to go from negative infinity to 2,000 and from 2,000 to infinity. An easy number to plug into my derivative would be 1,000. 1,000 times 0.4 is going to be 400. 800 minus 400 is positive. An easy number to plug in here would be 3,000. My test value of 3,000 goes in here. 0.4 times 3,000 is 1,200. 800 minus 1,200 is negative. So if my function is increasing until it gets to 2,000 and then it's decreasing, does that mean I have a max there? Yeah. So then I know that we're going to have a max revenue when x equals 2,000. Here's the nice thing about the problems we're going to do. They're designed so that you really don't have to check that. Because if you get one answer, that's always going to be the maximum revenue, the maximum profit, the minimum cost. But if you get two answers, you will have to check to see which one of those two is a max and which one is a min. So the only time you have to do this checking from here on out is if you get two answers for x. If you get one answer, you don't have to do the test because the problems are designed so that that's going to be your max when necessary, or your min if that's necessary. For example 2, what is the maximum revenue? Well, we got an x value of 2,000. How do we find the maximum revenue? What do we do with the 2,000? Yep, plug it into the revenue function. So R of 2,000 is going to be 800 times 2,000 minus 0.2 times 2,000 squared. I'm just doing that real quick. And we get 800,000. So we're going to make $800,000 revenue at that production level. Now remember though, revenue does not take into account our costs. Maybe we've paid $1 million for the plant where we're going to make these items. We would still have a negative profit if that were the case. So remember, this is just revenue. This is the money we're taking in. It does not take into account our costs. So the next problem does deal with cost. Find the number of units X that produces the minimum average cost per unit C bar for a total cost function of 1.25x squared plus 25x plus 800. The first thing I have to find is C bar. C bar is always going to be the total cost over X. So we're going to have to take this total cost and divide it by X. So our C bar then is going to be 1.25x plus 25 plus 800 over X. That's the average cost for us for 1 unit. We want to know the number of units that produces the minimum average cost per unit. So again, because we see the word minimum, that means we're going to have to take the derivative and set it equal to 0. So to take the derivative here, the derivative of 1.25x is just 1.25. That derivative is 0. This I need to think of as 800x to the negative 1 in order to take the derivative of it. So taking that derivative, 800 times negative 1 is negative 800, x to the negative 2. So that gives us C bar prime is what we just found, the derivative of it. So I'm going to want to rewrite that as 800 over x squared. And now I want to set it equal to 0. So if I'm going to set it equal to 0, I'm going to take this over to the other side. So I have positive 800 over x squared equals 1.25. I cross multiply. 1.25x squared equals 800. So to solve that, we're going to have to do 800 divided by 1.25, get that answer, and then what do we have to do with that answer? All right, take the square root of it. And we get 25.3, and it's really plus or minus, but we can't have a negative number of items. So we get about 25.3, but we can't have 25.3 units that we're going to produce. So we're going to have to just say that it's going to be 25 units. We'll have to round it. So that's going to be the production level that minimizes the average cost per unit. All right. Now, example 4, this kind of puts it all together. Find the price per unit P that produces the maximum profit, capital P. Here's the cost function. C equals 35x plus 500. Here's the demand function, our price function. 50 minus 0.1 radical x. We're trying to maximize the profit. So we need to have the profit function. Avery, do you remember how to find the profit function? Good. So that's what we're going to do. Here's our price function. I'm going to go ahead and multiply that by x. So when I do that, I'm going to get 50x minus 0.1. What's x to the 1/2 times x going to be? X to the... Look at it again, guys. This is x to the 1/2 times x. X to the 3/2. Yes, you have to add those exponents. So x to the 3/2 minus the cost. So to find the profit, let's simplify. 50 minus 0.1, x to the 3 halves. And then this will be negative 35x minus 500. And so just simplifying a little bit more, 50 minus 500 gives us negative 450 minus 0.1. Yeah. Oh, thank you. Yes. All right, so we are going to put this into descending order. So I'm going to have negative 0.1 x to the 3 halves, and then 50x minus 35x is 15x minus 500. So there's our profit function. What do we have to do with that profit function now in order to maximize it? Find out where the derivative is. What? What do we want the derivative to be, guys? What? 0. So I have to take the derivative. How am I going to do this? Negative 0.1 times 3 halves. What do I think of 3 halves as? 1.5. So 0.1 times 1.5 is going to be negative 0.15. X. Subtract 1. 1 half. This derivative is 15. So we have our derivative. Now we're going to set it equal to 0. I'm going to take this over. Okay, so now to solve this, I'm going to have to do 15 divided by 0.15. Hopefully you just know that's going to be 100. If you don't, get out the calculator. That's 100. So these divided, so now I have x to the 1 half equals 100. A lot of times people tell me that answer is 10. That's not right. What would we do to both sides? We're not going to square root both sides. We're going to do what? So square both sides. So you get x equals, when I square zeros, I just double the number of zeros, so it's 10,000. So x equals 10,000. We're finished. That's our critical number. That's going to be the maximum because I only got one answer. I know that's going to be the maximum. But that's not my final answer. Because what does the question ask for? Price. This is the number I'm going to produce. That's not my price. To find my price, I have to plug this back into my price function, which was 50 minus 0.1 square root of 10,000. We have to plug it back in. Square root of 10,000 was 100. 100 times 0.1 is going to be 10. So my price is 50 minus 10, so our price is $40. That's going to be the price that will maximize our profit. Remember, if we charge too much, people aren't going to pay that. If we charge too little, then we're not going to get our money back from what our cost was. Okay, so number 5 is just dealing with number 4. It says a company is maximizing their profit from selling a certain coat based on the situation described in number 4. What is the company's profit? Well, now we know the price, we know the number of items, so what are we going to do with those two to find, what's that going to do if I multiply those two? It finds our what? Revenue, right. So my revenue then is going to be 10,000 coats times the price of them, which is $40, minus our cost. So I'm going to have to do 35 times 10,000 plus 500. That's going to be our setup. Just put that whole thing in the calculator. 10,000 times 40 minus parentheses 35 times 10,000 plus 500. And I get 49,950. Did anybody else get that same answer? I thought it was 49,500. Did you guys get 49,950? Yeah, I think I left off a 0 on my number or something. Yeah. Okay, so yeah, it does end up being 49,500. And so that's going to be the company's profit. So even though their revenue was so high, 400,000, their cost was also high, so their total profit wasn't really that great. But maybe this is for a month rather than a year. You don't know what it is, or maybe it's for a day. Who knows? Okay, any questions on that? So that's what your worksheet's going to be about: maximizing revenue, maximizing profit, minimizing average.